Welcome to Crisil Point of View podcast on artificial intelligence and machine learning. I am your host Akanksha Gupta and we have Rachna Maheshwari, who is an expert in quantitative finance and modeling at Crisil. Today we explore AI ML in banking and finance with her.
Hi, Akanksha.
So let's dive right into it, Rachna. What are some use cases of AI ML in banking and finance?
A recent 2022 survey of 500 financial services professionals established that about 78% of financial companies use machine learning or deep learning. Thus, these innovations are being applied very widely. The most common use cases of artificial intelligence and machine learning in the banking and financial services industry are algorithms used for fraud detection, consumer analytics, credit risk quantification in retail banking, client interface applications such as chatbots, and trading algorithms used for portfolio and investment management. Now, if you get a bit innovative and futuristic, you can think of a future in which ATM machines will use image recognition and biometric data for identity verification and chatbots that'll provide investment advice.
Well, image recognition in ATMs can be a game changer. Also, we have such a wide set of applications in banking and finance. That leads me to the next question. Recently, you've written about how it is difficult to interpret and explain AI/ML models. Can you elaborate on this further?
In financial services, model outcomes are often submitted to regulators and may have to be provided to business leadership to facilitate decision making. Thus, it is important to be able to explain the models and methods used. In quantitative modeling, usually the modeler specifies or develops the quantitative model and selects the data attributes that will be used as inputs in the model. In machine learning, we have the flexibility to make the algorithm select the input data. We call this feature selection. We can also program the algorithms such that it selects the mathematical function at each decision node of the algorithm. Since the modeler does not select the data and specify or write the model, it is widely believed that these models are black boxes and difficult to explain. But that's not entirely accurate, as you would agree. These models are complex, but seasoned machine learning modelers will know and be able to explain the features being used and what the exact model specification is. In addition, there are also several statistical techniques available for facilitating post hoc explanations, which are highlighted in my blog.
So basically, it's a combination of models and methods to interpret, right?
Yeah.
Awesome. Also, how do technologies such as database and big data capabilities, cloud computing, and high performance computing help with AI/ML applications?
That's a great question. Artificial intelligence and machine learning models train on large volumes of data, such as customer data in retail banking or high frequency trading data. These are complex algorithms that require computational power. Cloud computing, database, and big data capabilities help with data storage. High performance or parallel computing capabilities drastically reduce the time taken to train the algorithms. Therefore, there are synergies in the use of all of these technologies.
Great. So thanks for sharing your insights, Rachna. This is getting further more interesting for all of us. I would like to continue this discussion with you on AI/ML in the next one, where we'll take up bias and fairness associated with it. So, listeners, do stay tuned to Crisil Point of View podcast.